Okay, so this is a previous example that we've looked at, the probability of A given B. And so we're in B, and that's the yellow area. So what's the probability of A? Well, that whole area is 0.4, and the A bit is that bit, 0.15. So the probability of A when we're given B has happened is 0.15 out of 0.4, and that's 0.375. But note that 0.15 is the probability of A and B, and the 0.4 is the probability of B, which gives us the following result, that the probability of A given B is the probability of A and B divided by the probability of B. It's absolutely crucial that you learn that result. Now we've got two more probability formula to learn. Let's see what they are. Suppose we have the probability of A occurring is A, the probability of B occurring is B, and the probability of them both occurring is I. So probability of A and B is the intersection, and that's the probability of I. Now, we're told that the probability of A equals A, which is that area there. Now, we already have I within the yellow area, so the remaining bit of A must be A minus I, because A minus I plus I equals A, which is that yellow probability. And similarly, the probability of B equals B. Now that's that yellow area there, but in that yellow area we've already got I in there, so the rest of the yellow area must be B minus I. Now, the probability of A or B is that yellow area there. And what are the probabilities that you can see? There are three of them that we need to add together. A minus I plus B minus I. And when you add those things together, you get A plus B minus I, and that gives us the following result, that the probability of A or B is A, which is a probability of A, plus B, which is a probability of B, minus I, which is the probability of A and B. So again, this is an important result, and I've just explained where it comes from. If you're not too sure about the explanation, then at least just remember the result off by heart. And we can rearrange that box to find the probability of A and B. So that's a rearrangement of the above result, and that gives us a second probability formula. So once again, folks, please, you need to learn that second formula as well. So let's apply what we have learned to our example. We want the probability of A and B. And we've just learned that the probability of A and B is the probability of A plus the probability of B minus the probability of A or B. And if we put our values in, it's a nice and simple calculation, and that's 0.4. Here's a second example. We want the probability of C given D. Now remember, the probability of C given D is a probability of C and D divided by the probability of D. That's what I explained at the start of the video. So we put the values that were given in the question into that little formula, and that gives us a probability of C and D 0.3 times 0.6, which is 0.18. For part B, the probability of D given C is not the same as the probability of C given D. It's a different result. It's the probability of D and C, or C and D, it's the same thing, divided by this time the probability of C. So that's 0.18 divided by 0.12, and that's 0.9. Finish off with part C. The probability of C or D is the probability of C plus the probability of D minus the probability of the intersection. That's the important result that we need to learn. So that's 0.2 plus 0.6 subtract 0.18, and that's 0.62. So a recap, those are the three formulae that we absolutely need to learn. The top one is a conditional probability, the second one is a probability of A or B, and the third one is a probability of A and B. So that's exercise 2D that needs doing. Crack on folks and get the job done.